All right, in this video, I'm going to demonstrate how I want you to proceed with tonight's homework. Please on your calculator right now do second plus 712, second plus 712. So you've cleared the RAM on your calculator. Now I'm going to choose to do this particular problem on a separate piece of paper because I write large and fairly sloppy. Notice I need to rewrite it in vertex form. I'm going to graph it and I will identify as ordered pairs what is the vertex, the y-intercept, and algebraically I'm going to calculate the x-intercepts. So with me, here we go. The very first thing I'm going to do is I'm going to rewrite this in vertex form. Please follow along with me. Now your AP exam, when you do the FRQs, which is the non-multiple choice portion, you need to show every single step, even when that's painful. And so that's what we're going to practice. I'm going to take the constant, and in this case, I'm going to add 3 to the opposite side. You're following along with me. Give yourself plenty of space if you're writing on a whiteboard. Okay, now I have that missing piece where the 3 once landed at the very back. Whenever the leading coefficient is any value other than positive 1, I must factor it out. 4 times 1 is 4, bring down the x squared. 4 times 2 is 8, bring down the x. How do I decide what value goes here? There's a way in which we do this. We look at this trinomial, and whatever the b value is, which is the value stuck with just the x, not the x squared, just the x, I take that value and the sign, and I always divide it by 2 and square it. Well, I know 2 divided by 2 is 1. Again, 2 divided by 2 is 1, and 1 squared is 1. Now, a large misconception here that happens often is students think you just added 1 to the right, and then they had the right idea, so they want to add 1 to the left to keep the equation balanced. But in fact, we did not just add a value of 1 to the right, we added a value of 4. So on the left-hand side, please do a plus 4 as well. Now I've kept the equation balanced. I have y plus 7 equals, and I could go off to the side and factor this trinomial, or there's a shortcut. You take and put an x in front of this portion, so x plus 1, quantity squared. And lastly will be to subtract the 7 back, and now I have rewritten this in vertex form. What I always want you to do at this point as we go through this is I want you to grab your calculator, and we're going to verify that these two are the same. That means that I correctly transform this into vertex form. With me, let's plug this in. The original and standard form is 4x squared plus 8x minus 3. Then I'll go to y sub 2 and type 4 times the quantity x plus 1 squared, subtract 7. When I look at the graphs, they need to be simultaneously on top of each other. So you see the blue and the red are. That means I feel very confident. I've verified that these two are in fact equivalent to each other, just in different forms. So I need to see this work. Next, what is the vertex? It lies to me and it tells the truth. So it lies to me, -1, it tells the truth, -7. I'm going to come off to this graph paper where I have a little more space, and you're welcome just to watch right now if you're doing this on the board. So I'm going to start by graphing the vertex, which is -1, -7. 1, 2, 3, 4, 5, 6, 7. Here's -1, 7. I can see that in standard form we have a y-intercept of 0, -3. So I'm going to graph that as well. Remember, all of these equations that you're working with right now are quadratic. And we've already gone through in a previous unit talking about the ordered pairs that belong to parent functions. So the parent function to y equals x squared has, and you have to have these memorized, we talked about that, it was previously on the board, -2 squared is 4, -1 squared is 1, 0 squared, 1 squared, and 2 squared. How is this going to help me? Remember, this is the equation I have. So I'm going to write that down. Y equals 4 times x plus 1, quantity squared, minus 3. Anytime there's a value out in front, it must be multiplied by the y values. 4 times 4 is 16. 4 times 1, 0 times 4, 1 times 4, 4 times 4. This is the 0, 0. I'm going to go once to the left and up 4. 1, 2, 3, 4. Once to the right and up 4. 2, 2 from the origin, from the vertex, 2 to the right and up 16. Now that's going to be pretty far off the graph. 2 to the left and up 16, right? So it's looking something like this. I need to see these distinct ordered pairs. Obviously, going up 16 will probably likely be off our graph. So I've graphed it. I've identified the vertex, the equivalent in vertex form, the y-intercept, and lastly is algebraically to determine the y-intercepts. So how can we do this? We can use the quadratic formula. If that's your preference, don't go ahead yet, but this will always work. Always this will work, okay? What's another method we could use, because you have to show algebraically? Sometimes factoring works. Not always, but sometimes factoring works. My preferred method is to take what's in vertex form, and just like when we find the y-intercept, x is 0. Well, when we find the x-intercept, y is always 0. So I'm going to write this down. If you're on the whiteboard, you're following along with me. And I'm going to replace the y with 0. What I want to show you by doing so is that the answer you may get may look slightly different than what you see on the answer key, and that's because the answer key has transformed it into really the proper form. So let me show you. Plus 7 plus 7. If you just came in, you need to show all of your work right now. Otherwise, you will redo this problem by yourself later on. Okay, so my goal is to isolate the x, and in doing so, I'll be able to algebraically determine or identify the x-intercepts. This tells me I'm going to have two answers. Well, how do I have two answers? Plus or minus 7 over 4. And lastly, I'm going to subtract 1 to both sides. So negative 1 plus or minus 7/4 equals x. This is what I believe the x-intercepts are. Now, if you looked at the answer key, they would apply the square root to the 7 and into the 4, okay? And so you're welcome to do that. You're welcome to do that, but I would be accepting of this. Now, how can we check? Because when you go online and you check the answer key, which I'm doing right now, give it a second here, you will see, okay, this is what we have. All of this looks good, but look at this answer does not look like what I have. And so you may be second guessing yourself, did you do it right? Well, here's how you're going to check. We're going to keep this calculator in front of us. With me, please do this. Go second, calculate, value. I want you to type this in with me. Negative 1 plus the square root of 7/4. Square root is on the left-hand side. You do have to hit the second key first. When we press enter, if we get y equals 0, it tells you this works. This is another form of the answer you just saw in the answer key. And we could do the exact same thing by subtracting. So I feel confident. This is my x-intercept, my vertex, my y-intercept, and I've rewritten it from standard form into vertex form. That is number 1.